Okay. Then hold on here. Let's go to problem 2 now. So problem two is milk exchange. And so milk exchange. So this problem is about a bunch of cows in a circle passing milk. So specifically, we have n less than 5 times 10 to the 5 cows in a circle, each with like some milk, or each with like AI initial milk, I believe. AI, or they start with a bucket. They start with a bucket with capacity AI. Bucket capacity AI, like a milk bucket, and are also all initially full. And so what happens is that at each second, what happens is each cow will basically transfer all of their milk to the next cow, the one to the right. They will transfer all of it. Um, and basically, this cow will transfer all of its milk to the next cow, and at the same time, they will receive all of the previous cow's milk. So it's a simultaneous action. It's like this cow passes all of its milk to the next one at the same time that it receives all the milk from here. So, and then after the exchange, if any cow has like more milk than like their bulking capacity, they just discard the extra milk. And so we want to know, basically we simulate for like n time steps. And for each time step, after each minute, we want to know what is the total amount of milk in the circle. So we want to know the total amount of milk after each minute. So like after minutes 1, 2, up to n. All right, so how can we approach this? Well, let's kind of look at it from perspective. Well, first, let's kind of make sense. Like let's make better sense of like what this capacity, this like bucket passing like and then cutting off the excess milk. Let's figure out what that really means, right? Um, I'm gonna take a sample array. I'm gonna do the sample input actually. The sample input gives us 2, 2, 2, 1, 2, and 1 as the milk capacities. And then what happens is that after the first second, this cow will pass to here, 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 and pass to here. And specifically, this cow is only going to receive 1 milk from the previous cow, so it's going to have 1. And this cow is going to try to give 2 milk to this cow, but it's going to be like too much. So basically, like this cow's been trying to give 2 milk to this cow, but this cow cannot hold 2 milk, so it'll only keep 1 of it. So we basically lost like 1 unit of milk. And then this cow is going to give just 1 unit of milk to this cow. And so you can see that what's really happening with these operations, what's really happening is that we're just doing like each AI is set equal to the minimum of itself and AI minus 1. That is what's really happening with that's really what's happening with this operation. And when I say AI minus 1, the one before index the one before index 1 is like index n. So it wraps around in a circle. Okay. Given that's the case, so that's a much more like a kind of like a mathematical way of looking at this looking at what's happening here, and it's probably much easier to analyze now what the total sum would be after each minute. So let's analyze that now. In a sense, to get to the full solution of this problem, we need to look at it from the perspective of each milk, like each cow's milk, how much does it contribute to the answer at each time step. So I'm going to focus on a single cow that initially has X units of milk. And I'm going to look at like how many times do we like add X to like each of the time steps, each of the answers of the time steps. So after the first second, this cow will pass its milk to the next one, to the next cow. And then if they have enough capacity, they will also have X milk. So it will be plus X to the answer. And then after the next minute, they will pass again and again. And at some point, it will hit some value, unless they're like X is just the maximum, which is kind of like a special case. But at some point, let's suppose at some point we hit some element that is greater than X. That means that after this time step, this cow, when it tries to pass milk to the next cow, it will be it basically will get or actually sorry, when it's greater than X, that's fine because it's setting the minimum. At some point it will reach some cow with less than X capacity. And so when this cow tries to give all of its milk to the next cow, it can't give all of it. It's limited by what this value truly is. So in essence, like for all future time steps, it will be influenced by this value instead of by this value for when passing it further around the circle. So we say that X basically contributes to here, 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 and here after each second or each minute, but it doesn't contribute here. Its contribution stops spreading once it gets to this cow. On a similar note, we can think about what happens before it. What happens before it is like, let's consider the closest cow that is actually less than X. Then this less than X cow will continue to spread its influence of each time step until eventually it gets to here and it will override this value. And it will override this value, and so on. And so essentially, for each cow with initial value of X, we should think about its closest element to the left and right that are strictly less than it. And I'll talk about how to deal with tiebreakers if there are multiple cows with the same amount of milk. Actually, for that, it's pretty straightforward. What you do is you basically just tie break on the index of the cow. So you make some arbitrary choice that like if cow 1 and 2 both have 5 units of milk, we say 1 is less than 2. And that's just to be consistent, so we don't like overcount the same cow milk quantity multiple times. But yeah, now we just need to find the closest elements to the left and right that are that are less than this current cow. And then what happens is, so without loss of generality, suppose the left is closer than the right. So suppose the closest the closest cow with less milk, its closest to this cow is closer than like this cow to its next like smallest milk on the right. And what happens is, let's look at the contribution to the answer at each time step. So I'm going to have a time and I'm going to have the answer. So at time 1, 2, 3, 4, 5, 6, and so on. Let's look at this. We have X. What happens is at the first time step, it's going to spread to the next one. So it's going to basically contribute to both its own position and the position of the cow next to it, because both of these cows are going to have this value of X. So it's going to contribute +2. And the next time step, it will spread its influence again to the next cow. So it'll be +3 now. And then the next time step, it will be +4, and so on and so forth. And we say that at some point, the cow behind it with like, or the milk value, the value behind it that's like less will catch up to it and start like overriding these values. And so what happens is at some point, this will reach up to like some +y and it will stay constant +y because each time it will gain one more influence to the right, but it will also lose one influence on the left. And then finally, at some further points, it will hit like some less than X value on the right. And so at each future time step, this value will no longer keep spreading to the right, but the one to the left will continue to override all its previous values. So it's going to start going down, like y minus 1 plus y minus 2, and so on down until it reaches the end. So in summary, it's the contribution to the answer. If we imagine like the answer array as like a array of size n, then our contribution to it is like it's going to go +2, +3, +4, so on and so forth. So we get some constant value +y, and then we're going to go back down again. So basically, you can think of it as there are 3 kind of like distinct ranges where like stuff is happening. One of these ranges is where it's going to be going up like an arithmetic progression, like 2, 3, 4, so on. One of them is going to be constant, and one is going to be going down, like y minus 1, y minus 2, y minus 3, and so on. And so this problem really just reduces down to, we need the ability to add an arithmetic progression to a range on an array. Right? If we're able to do this, then we have solved the problem, because then each element's contribution to the answer is just going to be like a sum of at most 3 different arithmetic progressions onto the answer array. So let's talk about how to do this subproblem. Add arithmetic progression to a range on an array. And this is actually turns out to be a classic problem that you can solve with prefix sums. So how do we do this? Well, the trick is, well, let's look at it this way. Let's say you want to add something of the form like +a plus A plus D, and then plus A plus 2D, plus A plus 3D, and so on, right? Let's say you want to do this to the array. Then what happens is, yeah, that's what we want to do, right? So let's look at the so it's kind of hard to like directly do prefix sums of like directly with prefix sums create an effect of like plus A plus D plus A plus 2D plus A plus 3D and so on. But let's look at the difference array instead. So in the difference array of the true like values, what happens is that in a difference array, what happens is that at each of these positions we do plus D plus D plus D plus D plus D and so on, right? Basically the difference array is going to be increased by D for over a continuous range. And then finally, if you take this a difference array one more time, you consider the difference array of this. If you consider the difference array of this, then it's just a plus D in a single position, and like eventually it'll end. So we will minus D like at some other position. So now if we kind of go 2 layers down, we are able to do a constant time update to the table. So basically what we do in summary is we want to add an arithmetic progression. I kind of ignore the plus A here. So the plus A is going to be like one of these is the first one's gonna be plus A. That's like an exception. We can deal with that we can deal with that some other way. But the premise is that like that's like some other thing. But the premise is that if you have what you do is like if you want to add like let's say you want to add like assuming A is 0, you want to add like 0, D, 2D, 3D, 4D, so on and so forth. You add D at some position and you add minus D at the end of the range, and you take a prefix sum on this. And if you take a prefix sum on this, what the effect is that you basically add D to like a range of different values. And if you take a prefix sum of this again, then the effect on the final array is that you do plus D, plus 2D, plus 3D, plus 4D, and so on and so forth on the array. And that is the desired effect that you want to achieve. And so ultimately, with this trick, we are able to add an arithmetic progression to any range on an array just by doing prefix sums twice, right? Because when you do prefix sums twice, what you do is you effectively accumulate this distance, the D on the array by exactly the right amount, which is D, 2D, 3D, 4D, and so on and so forth. And you can stack these updates for multiple different arithmetic progressions you're adding. And so what this means is that now we're able to solve the subproblem. That means that for each element in the circle, we just figure out its contribution to the answer array, which is at most 3 distinct ranges. We add an appropriate arithmetic progression, and then we compute the final answer array with one sweep at the very end and print all of it out. And that should take, in total, nothing we ever do exceeds linear time. So this is a linear time solution. All right. So any questions on the second problem? Any questions?